Okay, year 12. So this is a lesson on the bivariate data review of chapters 1 and 2. So just so you're aware, everything that we did before the PSMT and leading up to the PSMT, which is on bivariate data, any of that can be assessed not only in IA2, which is your exam at the end of this term, it can also be assessed in the external exam. So we can't forget about it. So this is a pretty big PowerPoint, but I'll try and go through it quickly. It is just reminding you all of the concepts that we learned last year, at the end of last year, sort of during the end of term 3 and term 4, whilst we were completing the PSMT. It's easy to forget some of these because when you're completing a PSMT, you're so focused on doing your PSMT really well, you sort of forget that there's some stuff that we could be examined on. So that's the purpose of this PowerPoint. So look, for this PowerPoint, I think you should best, if you had your notebooks, your maths notebooks open, and you're probably best to take a couple of notes only if you need to. Some of this stuff some of you will be like, yep, I already know that. Don't worry about taking the notes. But if you get to something or some example questions and you think, oh, I don't know if I know that, it's probably worthwhile copying that down. When you come back, the first lesson of you coming back, I'll actually just quickly show you. Okay. The first lesson of you all coming back. Content library. Okay, you'll see if you scroll down the OneNote, it's actually going to be a bivariate data review. So we're going to give you just a worksheet on all of this sort of stuff, and you guys are going to have to be able to answer it. So make sure you watch this video. So learning goals. These are basically all the things you did at the end of last year. So the chapter 1, I will be able to identify explanatory and response variables, construct and interpret two-way tables. So that's something that you probably thought, did we even do that? We did it at the very end of the unit. Because it wasn't related to your PSMT, we didn't teach it during the PSMT, but you can be asked to answer questions on that in your exam. Construct and interpret scatter plots, calculate and interpret correlation coefficient and coefficient of determination. Those were all chapter 1 topics. Chapter 2, you need to be able to calculate the least squares regression equation using a calculator. So we did it on Excel, but can you do it on a calculator? Because you need to for the exam. Can you make predictions using the least squares regression equation? That's supposed to say, not calculator. Can you interpret a residual plot? And can you understand the difference between association and causation? So let's go through. The first lot is chapter 1. So identifying variables, just a reminder. So if you're investigating a question, does the time it takes a student to travel to school depend on the mode of transport? Actually, before I do this, if you find that you feel quite confident with these, you may not want to listen to the video. You may just like to go through the PowerPoint at your own pace. If that's you, then stop the video now. If you do want me to generally run over all these concepts with you, it's probably wise to watch the whole video. Okay, so we wish to investigate the question, does the time it takes a student to travel to school depend on their mode of transport? So the variables here are time and mode of transport. Which one is which? Well, which one explains the other? So does someone's time taken to arrive at school, does that explain the mode of transport, or does the transport explain the mode of time? And hopefully you're thinking that it's the transport that explains the mode of time. So the transport then is the explanatory variable and time is the response variable. That's just a quick review of that. So constructing and interpreting scatter plots, we did this on Excel, but we don't need to worry about that for the exam, but we do need to be able to create these by hand if we're asked to in an exam. So just a reminder, the most important thing, the explanatory variable is on the x-axis, okay, which means the response is on the y. Make sure you use appropriate scale, and your scales should be even. If you jump numbers at the start of the y-axis, you need to truncate the axes. So I'll give you some examples. Okay, so on the next few slides, we'll illustrate how to construct a simple scatter plot by comparing number of ice creams with average temperature. So draw the axes, label them, EV on the X, RV on the Y, and choose an appropriate scale and plot the data. So here's an example, the temperature and the number of ice creams sold. So which one's explanatory and which one's response? So temperature will usually will explain ice cream sold. So temperature needs to be our x-axis. So what we do is we look for the highest and lowest x-axis value. So you can see that the lowest is 15 and the highest is 30. So we will draw an axis, okay, that goes from 15 to 30. And then we need to do the same for the y value. So y will be the number of ice creams sold because that's a response variable. The lowest number of ice creams sold was 50. The highest was 100. So we'll need to make sure that that axis goes from 50 to 100. Okay, and here's an example of that happening. So once you've drawn your axes in, so you can see that little squiggly section, that means the axes have been truncated. Okay, you go put your variables down or put your different values down for your axes, and then you need to go through and plot the different values. So temperature of 21 and 70 degrees, so you go 21 up to about 70 and you plot your point. Okay, this scatter plot does not have a line of best fit attached to it. That's fine, there's no need to do that yet because the question hasn't asked us that. So that is that. Correlation coefficient, what is it? How to calculate it? So a quick reminder, correlation coefficient is a measure of the strength of correlation, the strength of the relationship. Okay, so remember, if the relationship is going in so this one here is probably the best one to look at to start with. If it's going upwards, it's a positive relationship, okay, and that strength is really quite strong. So we say it's like by eye, it looks like about plus 0.9. Okay, here's another one, this one here. It looks a little bit random, but it's not. There's a clear pattern of it moving upwards. So we say that if we drew a line of best fit through here, we'd say that this has a correlation coefficient of approximately plus 0.5. Okay, these ones here and here are negative. Okay, they are going down. Okay, a reminder, if correlation coefficient is 0, that means there is no relationship. So that would just be random points everywhere. So this one here is quite weak. Its correlation coefficient is negative 0.3, and this one a little bit stronger. Okay, you can see that if we drew a line of best fit, it would quite accurately describe these points. So they're approximately by eye, it's negative 0.7. Okay, strength of correlation can be further classified based on this table. Okay, so anything within these realms, so anything less than 0.25, okay, is actually considered no correlation. So we just say there's no linear association. So that's a table that gives you that. We need to be able to calculate R with a calculator. So I actually, if I can, I'm going to pause the recording and get a scientific calculator up, and you guys need to get a scientific calculator out, please. Okay, so I'm going to continue recording. On the left, you can hopefully see I've just got this is actually one of the green calculators. If you have one of the green calculators, this should be the exact same. If you have one of those black calculators like this, you can just watch this little video here, which will show you how to calculate R if you can't remember. And this one here will show you how to calculate it if you have one of the green calculators, which is called the Texas Instruments calculator. So let's skip ahead to an example question. And I want you guys to actually do this question. So the price and age of several secondhand dirt bikes is listed in the table. Calculate the value of the correlation coefficient, giving you an answer to 3 decimal places. So what we actually need to do is we need to go into statistics mode so we can enter all of this data. Okay, so we're going to go, whoops. Okay, so we're going to go into data. Okay, and inside, if you're using the other calculator, I think it's like shift or mode stat, okay, and you're doing 2 variable data. So then in list 1, we're going to go and list all of the X values, okay, and we have to determine, does age determine the price of a secondhand bike, or does the price determine age? And the correct answer is age determines price. So that's our X variable. So it's easy if we just put that first. So we just go through and put all the numbers in there, and then we go across to list 2, and we put all of the values in there. So I'm going to pause the video. You should too, while you go and do that. Okay, so I've gone through and put all of those values in, and then once I've done that, okay, I can use the calculator to find the R value. So to do that, you're going to go second function, stat, which is above data, so stat. We're looking at 2 variable statistics, so if you just press 2, you go into that. We've got our X data as list 1 and our Y data as list 2, so that's all good. So enter, and we can calculate. Okay, and then here it's going to give us all these different values. So we need to scroll down, okay, and we are looking for the R value. And you can find here that we've got the R value. You'll also notice actually here that there's an A and B value. That will be really important a little bit later in this PowerPoint. So if you can remember, any bivariate data, you just put them in both lists, X and Y, and then you come here and you'll find some different values. So our R value, negative 0.88, and it's to 3 decimal places, so we're going to have to round that up to a 9. So it's negative 0.889. Okay, and then it says B, classify the strength of this association. So I'll just skip ahead to the answers. So the correlation between the age of dirt bike and price is strong. How do we know it's strong? Well, you just go back to the couple of slides up, and you see anything between negative 0.75. Anything between negative 1 and negative 0.75 is a strong negative linear association. So we just say it's strong. Okay. So as the age of a dirt bike goes up, its price actually goes down. And that makes sense because the older a dirt bike you buy, it should cost less usually. Okay. So I'll make this big again. So coefficient of determination. So this is pretty easy once you've got the correlation coefficient. So coefficient of determination is the degree to which one variable can be predicted from another linearly related variable. And it's called the coefficient of determination. And it's just R squared. So to find it, if you know what R is, you just have to square it. So in this example, we're doing 0.8. If we used our last example, we would just square that value. Notice you'll always come up with a positive number because any negative value squared will give you a positive, and any positive value squared will also give you a positive. Okay, so just remember that. So interpreting the coefficient, this is the most important thing, I guess, out of this. So the coefficient of determination as a percentage tells us the variation in the response variable that is explained by the variation in the explanatory. You did this for your assignments, your PSMTs. So the coefficient of determination tells us, so here it was 64%, and it was correlation between weight and height. Okay, so it tells us that the coefficient of determination tells us 64% of the variation in people's weight is explained by the variation in their heights. Now, percentages always go to 100, so what's remaining is 36, which means that 6% of the variation in people's weights is explained by other factors. This could be sex, lifestyle, their build, etc. Okay, so here's another example. Example question and solution. So carbon monoxide levels in the air and traffic volume are linearly related. Determine the value of the coefficient of determination and write it in percentage terms and interpret. So we just have our R value squared. So we do 0.985 squared, which gives us 0.97. We turn it into a percentage by timesing by 100, 97%, and then we write a brief explanation. So the coefficient of determination tells us that 97% of the carbon monoxide levels in the air are explained by the variation in traffic volume. So it's quite a large amount. This clearly shows that traffic volume is an excellent predictor of carbon monoxide levels in the air, as only 3% of the variation of carbon monoxide is explained by other factors. And that's Chapter 1 review. Now Chapter 2. Now Chapter 2, this was the part on like least squares regression and residual plots. Now, I might stop the video now and stop this video, and I'll create another video on the Chapter 2 review.